everyone. This is R. Suresh Kumar, working as Assistant Professor, Institute of Aeronautical Engineering, Dundigal, Hyderabad. In the previous lectures, we discussed about the irrigation and the types of the irrigation and also methods of the irrigation. Is discussed different types of methods to applying the irrigation methods also discussed in the previous class. And also what are requirement of the crop, just like duty and delta and base period also discussed. Today we will solve some problems regarding the duty and delta and the base period. Next two. Okay, so as per duty, as you know very well, the total depth of the water can be in how much depth of water can be required for the entire crop is delta. That is the delta. Next is duty. What is the duty? The duty of the water is the relationship between the volume of the water through that area of the crop it meters. That is we call it as the duty of the water. So then what is the base period? In this base period, the expression we have to discuss the unit discharge of the flowing for a time equal to the base period of the crop, called base of the duty. That is we discussed. So we have solved from there is some relationship between the duty and delta and the base period. That is equal to delta is equal to 8.64 B by D in centimeters, or delta is equal to 8.64 B by D per meters. This is the expression for the relation between the duty and delta and the base period. Here B is equal to base period, D is the depth of the water, that is called duty. So that is today we will solve some problems regarding this one. So let us see the one problem very important in the irrigation. The first value, if the rice requires for 10 centimeter depth of the water of an average interval of about 10 days and the crop period for the rice is equal to 120 days, find the delta for the rice. He is asking that find out the delta for the rice. So from the given in this problem, so the water requirement of the crop 10 centimeter depth of the water and average interval of 10 days. That is, we have to be remember on certain crop we have to the interval of the time is equal to 10 days of the each of the crop. So the water requirement of the requirement and interval of 10 days for the period of 120 days. Hence number of required waterings is equal to 120 by 10. That is means a total number of days for the crop is equal to, we are assuming 120 and divided by how much times? 10 times we have the interval of 10 days we are applying the water. So that's why 120 divided by 10, that is equal to 12. Next therefore total depth of the water required is equal to number of waterings into depth of the waterings. So here it is, we have already 12 is equal to, from the number of waterings for the total entire crop is equal to 120 by 10 is equal to 10, as we know very well. From this one, what we have to find out, if the depth of the water required is equal to number of waterings into depth of the watering, that is equal to 12 into 10 centimeters, that is equal to 120 centimeters. And hence delta for the rice is equal to 120. What we are required for the delta for the given the crop of the rice is equal to 120 centimeters. From this one, this is the very important problem in the irrigation purpose. Everybody in the asking the examinations also every time it will give us. Next, this is the next problem. We have to see problem number 4. Find the delta for the crop of the duty. Here is the different duty for 864 hectares for cubics on the field. The base period for this crop is 220 days. What we have to find out? Here also find out the delta. What you have to find the delta. Here the base period how much given? B is equal to given as 120 days and D is given as 864 hectares cubic. That is the certain given the duty. So that is the D is equal to 864 hectares. So from this one we have to find out the delta. So we know very well from the basic formula, delta is equal to 864 B by D in centimeters. Whether it is, take it as 8.64 B by D is when we say about the meters. So that is the basic formula to find out the duty and delta, whatever it is. From this basic fundamental formula, you have to find out anything. For suppose there is a duty and delta and base period also. So delta is equal to here, what your directive we have to apply here, 8.64 B by D centimeters and 864 into 120, that is equal to base period already given, divided by 864, that is equal to D. So that is equal to 1 centimeters is given. So that is the total find delta of this duty of the 160 hectares of the is equal to 120 centimeters. That is equal to delta. Here is delta value is equal to 120 centimeters. This is the another problem is given. So next we have to move on to the another problem. Here another problem. The wheat is required about 7.5 centimeters of the water. After every 28 days, what happens? And the base period for the wheat is equal to 140 days. Find out the value of the delta for the wheat. Find out the value of the delta for the. But I will keep it as 2a means this is also regarding the above related to the above the problem. So that's why here what is the we can understand first number of required waterings is equal to total number of days is equal to 140 days, and each of the every 28 days of the we have to applying the water for the fields. Okay, so from this one what we have to find out, 140 divided by 28, that is equal to 5. And again the depth of the water required for each of the time is equal to 7.5 centimeters. Depth of the time each of the required is equal to 7.5 centimeters are given. From the total depth of the vase, total is equal to, here is 5 times you have to applying the water in the interval of 28 days. So from this one the total depth of the vase is equal to 5 into 7.5 centimeter, that is equal to 7.5 centimeter depth, which is already given in the data problem. So multiplied by 5 into 7.5 centimeters, that is equal to 37.5 centimeters. So the delta for wheat is equal to 37.5 centimeters. This is the problem. So here is the from different small change variation the previous one. This one, find the value of delta, but here the wheat required 7.5 centimeters of the water applying the 28 days is given like that. So in the previously 10 days like that. Anything you have to find from the basic formula, you have to find whatever it is, you can solve this one. Let us see another problem regarding the problem number 3. So let us see, here you can understand thoroughly. An irrigation canal has the gross command area of 80,000 hectares, out of which 85% of the culturable irrigatable. The intensity of the irrigation in the Kharif season is 30% and the Rabi season is 60%. Find the discharge required at the head of the canal if the duty at its head is equal to 800 hectares per cubic for Kharif season, 1700 hectares per cubic for the Rabi season. So from this formula you have to find out the gross command area is equal to 80,000 hectares. So before going to that, what is meant by gross command area? Gross command area is the area which is the total what we have to find out the total area what we have to find the irrigation purposes. So some of the, whether it is cultivated or non-cultivated, both will be mixed in the gross cultivable command area. That's why we call it as gross command area. That is the total area, which is the, you have to find out. That is equal to 80,000 hectares is given in this formula. Next you have to cultivable command area. The cultivable command area is nothing but the area which is cultivated on from this total gross command area. That is the, you have to find out the culture, we call it as cultivable command area. This cultivable command area, how much they are given in the, so 85% of the is cultivable. So total area 85% is cultivable. That's why 80,000 into 0.85 is given. So that is equal to 68,000 hectares area under the irrigation. Next, Kharif season, what happens? Another is given the Kharif season. There is a 30% as given. 30% of the Kharif season is given. From this one, what we have to find? The 68,000. Whatever the cultivable command area, from this one we have to find the 0.30. Not for the 80,000. This point you have to remember carefully. 80,000, 68,000 into 0.30. That is equal to 20,400 hectares. 20,400 hectares. Next, area under the Rabi season. Area under the Rabi season is equal to 68,000 into 0.60. That is equal to 40,800 hectares are given. So, Kharif season is equal to 30. So, total area, first what we have to done? Total area, how much there is a cultivable area, means which is used for the irrigation culture or whatever the crop. So, the crop area we have to find. So, that's why 85% we have to find out the total area 68,000. From the 68,000 we will find out the Kharif season as well the under the Rabi season. We are bifurcating the Kharif season, a different percentage is given, and the Rabi season is also given the different percentages. So from this Kharif season and Rabi season, what happens? 68,000 into 0.60, that is equal to 40,800 hectares. That is the find out the total area. These are very interesting problems, so very important, and also in the real time it can be applicable also. So water requirement for the head of the canal Kharif is equal to area by duty. So how much you are? 20,400. 20,400 is from the Kharif season divided by 800 hectares. That is equal to water requirement head of the canal of the Rabi is equal to area by duty. That is equal to 40,800 divided by 1,700. That is equal to 24 cubics. 24 cubics. So since the water requirement of the Kharif is so that the canal may be designed as per the 25, as per the requirement, you have to find the design the canals. That is the availability of the water. You have to find the all the irrigation structures. Okay, right. Next, let's see the another example is also there. So water, a water course has a cultivable combined area 2,600 hectares, out of which the intensities of the irrigation for the present perennial sugarcane and rice crops are 20% and the 40% respectively. 20% and 40% respectively. The duty of these crops, of the head of the water course are 750 hectares for cubics and 1800 hectares cubics respectively. Find the discharge required for the head of the water course if the peak demand is 20% of the average requirement. What we have to find out? So find the discharge required for the head of the water course in the peak demand is 20% of the average requirement. So let us see that one. The cultivable command area is already given in 2600 hectares is given. And what happens from this the area under the sugar cane already given in the 20% is in the above which is already mentioned. 20% is already given the mention here. And area under the rice, the area under the rice is equal to 2600 into 0.4, that is equal to 1040 hectares given. And water requirement for the sugarcane is equal to total area divided by duty, that is the total area water requirement of the sugarcane. So area by duty, that is equal to 520 divided by 750, that is equal to 0.694 cumex. That is the total requirement of the for sugarcane. And water required for the rice is equal to area divided by duty. Area divided by duty, that is equal to 1040 divided by 1800, that is equal to 0.577 cumex. So water requirement crop is equal to 0.577. Up to this, what we have to done? Water requirement of sugarcane is equal to area divided by duty. So that is equal to 0.694 cumex. Next, water requirement for the rice. Then another crop is also there. Also area divided by duty, that is equal to 1040 divided by 1800, 0.577 cumex. Next, the sugarcane is the perennial crop. It will require the water throughout the year of the hens. So that is the water requirement of the crop is the sugarcane is more. So that is why we will get throughout the year it can be known. So the water must be carrying the discharge of 0.694 for the requirement of sugarcane plus 0.577, that is equal to requirement of the rice. So okay, the total requirement is equal to 0.694 plus 0.577, that is equal to 1.274 cumex. This is the total water requirement of the must two crops as sugarcane as well as the rice. See another example, very interesting example. Let us see. I collected this one as the Punmiya textbook. You can refer any of the dots from the Punmiya, BC Punmiya of the hydrology. Now, left branch canal. See, very interesting problem. The left branch canal carrying the discharge of 20 cumex has cultivable command area is equal to 20,000 hectares. The intensity of the Rabi crop is equal to 80% and the base period is equal to 120 days. The right branch canal carrying the discharge of 8 cumex has the cultivable command area is equal to 12,000 hectares. The intensity of the irrigation for Rabi crop is 50% and the base period for is equal to 120 days. Compare the efficiencies for the two canals. Here what he has given, the two canals is there, two canals the base delta is different and the cultivable command area is also different. From this one you have to find the what in the right canal is given and also the comparison between the two canals. So let us see the first one. For the left branch canal, first let us see that. In the left branch canal, what I have given, a area under the Rabi crop is equal to the cultivable command area is 20,000 into 0.8% and multiplied this one 16,000 hectares. That is the area under the Rabi crop. And the discharge is equal to 20 cumex. This already given in the example given data, that is equal to 20,000 cumex is there. Next, the Duty is equal to area divided by discharge. That is equal to 16,000 divided by 20. That is equal to 800 hectares for cumex. 800 hectares for cumex. That is the duty. Next, crop B. The area under the irrigation is equal to 1200 into 0.35. That is equal to 420 hectares. That is equal to 0.420 hectares is there. Next, core period is equal to B is equal to 15 days. For core depth is equal to 16 centimeters are given, is equal to 0.16 meters. Now, what we have to find out the duty. The 8.64 B by whatever delta is equal to core depth. That is equal to 8.64 into 15 divided by 0.16. That is equal to 10 hectares for cumex. Next, thus the design, the discharge canal has the 0.278 plus and 0.518. Adding of these and also this is equal to 0.796. The design of discharge can be let us say it as 0.8 cumex of the water is flowing from this left side of the canal. Let us see. For crop B. Also, the total area we have to require 0.8. From this one, we have to find the how the canal can be discharged. From the discharge only, the availability of the water only, we have to design the canals or reservoirs, whatever it is. Right? Next, a water course has the already over I think so. So a water course has in command of the irrigation area is equal to 600 hectares. The intensity of the irrigation of this area is equal to 60%. Transplantation of the rice takes 12 days, and the total depth of the water required is by the crop is equal to 50 centimeters on the field during the transplantation of the period, and find the duty of the irrigation of the water for the crop on the field during the transplantation at the head of the field, and also the head of the distributary, assuming the losses of the water to be 20% in the water course, and also the calculate the discharge required for the water course. Also find the discharge for the water course. Rice seed in the initial germinated and separated of the seeds. Okay, let us see that one. After the withdrawals of the seeding of the young plants, right, so you have the transplantation of the prepare of the land for this young stage. Transpiration now can be 10 to 15 days required for the quantity, that is equal to 32 to 60 centimeters of the field. So transpiration after the 10 to 15 days required, the quantity of the water is equal to 30 to 60 centimeters of this field. Preparation of the land for the includes throughout the saturation before plugging. When delta is equal to 8.64 B by D, where B is equal to transportation period of 12 days and the delta is equal to irrigation water actually applied in the field. 50 minus 10 is equal to 40 centimeters, that is equal to 0.4 meters. D is equal to duty of the irrigation water of the field hectares in the due. Next, 8.64, when calculating 8.64 B by D, that is equal to base period you have to duty. Duty is equal to D is equal to 8.64 B by delta. So the general formula is delta is equal to 8.64 B by D. That is the basic formula. So from this we can to find changes as per our requirements. That is equal divided by delta value is equal to 0.64. That is equal to 259.5 hectares per cumex. The duty is also on the field. Next, duty on the field. Since the losses of the canals is 20% is given and 1 cubic meter of discharge head losses are also given the 0.8 cumex. And hence the irrigation is equal to 225.5 into multiplied by 0.5. That is equal to 207.6 hectares only. Hence the duty of the water requirement is how much? 207.6 hectares for the cumex. And from this one, the area on the rice plantation is equal to 600 multiplied by 0.6 will be taken. That is equal to 360 hectares. But discharge of the head of the water course is equal to 360 hectares divided by whatever the duty of the water is equal to 207.6 hectares will be divided by 207.6, that is equal to 1.735 cumex. Next, see the another problem is also there. A table is given below. Below gives necessary data about the crop, their duty and the area of the crop command by the canal taking off from the storage of the reservoir. Taking the time factor for the canal is equal to 13/20. Canal for the discharge required for the head of the canal. The capacity of the factory is 0.8. Determine the design discharge. We have to find the design. From this one, what they are given? Canal taking the factor of the canal to be 13/20. So let us see. Already given one of the from the tabular file given sugarcane base period is equal to 320. Overlap sugarcane 190, wheat 120, base air as 120, and vegetables is 120. Area, how much area can be hectares? 850, 120, 600. 500, 360 and 580 and 580 and 1600, 2000 and 1600, like that they are given. So from this one, discharge requirement of the crops of the sugarcane is equal to 850 divided by 580, that is equal to 1.465 hectares discharge for the overlapping the sugarcane is equal to 120 by 5, that is equal to 0.77 hectare. Discharge for the wheat is equal to how much? 600 divided by 1600, that is equal to 0.375. For discharge for the basery, that is equal to 500 divided by. These are already given in the data, already given 500, 600 already. You have to find here. From this one, you have to take the values. Next, vegetables is equal to 360 divided by 600, that is equal to 0.60 cumex. So next, sugarcane of the Rabi season of 320 days was given. From this one, discharge calculation for the Rabi is equal to 1.465 divided by 0.6. What is 1.465 and 0.375? In the previously 1.465 is equal to discharge of the sugarcane, and also 0.375 is equal to overlapping the sugarcane value, that is equal to 0.375. So total adding of these two, we have to total 1.864 cumex is given. Next, discharge required for the monsoon is equal to 1.465 plus 0.25, that is equal to 1.685 cumex is given. And discharge required for the hot weather is equal to 1.465 and 0.25, 0.60, that is equal to 2.275. After adding all those things, 2.275 cumex. That's the maximum value of discharge for the 2.275 cumex in the hot weather condition. Next, the time factor is equal to, as given in the data, 13/20 is therefore. So full supply discharge canals can be 20,272 into 20/30 is given, divided by 30. It can be from the taking on the one side, it can be by 20 divided by 30. That is equal to 3.32 cumex. Since the capacity curve 0.8 hectares and design discharge is equal to full supply discharge divided by capacity factor, that is equal to 3.32 divided by 0.8, that is equal to 4.15 cumex. That is the final value. You have to find the design discharge value of the different types of the crops which is already given. See, the another problem is also there. So The base period for the intensity of the irrigation and duty of the various crops under the canal system is given in the table below. Find the reservoir capacity if the canal losses of 20% and the reservoir losses are 12%. Canal losses is 20%. And the reservoir losses. The losses can be whether it is evaporation, infiltration, whatever it is, the losses can be both the canal as well as the reservoir also. This is also one of the given in the data wise, wheat like that, sugarcane, cotton, rice and vegetables, and the area under the hectares can be irrigated is 4,800, 5,600, 2,400. Duty of the held is hectares 1800, 800, 1400, 900, 700. So solution, take it as the value of 1 by 1 we have to find. Wheat, discharge required is equal to 4,800 is already given 4,008 hectares divided by duty under the field, that is equal to 1800 can be cumex can be taken. That is equal to the volume of the water required is equal to total 4,800 divided by 1800 into base period number of days is equal to 120, base period of 120 days. So that is the 320 cumex of the day, like that. Sugarcane is also take it like that. Discharge required is equal to 5,600 divided by 800. The volume of the water required is equal to 5,600 divided by 800 into 360. So this is all the base, all the way in the base period of for this sugarcane crop. So that is multiplied 360. That is equal to 560 cumex per days. Next, cotton. The cotton discharge required is 2,400 divided by 1,400 cumex. The volume of the water required is equal to 2,400 divided by 1,400 into 200. That is equal to 342 cumex days. That is equal to another. Next, rice. The rice discharge required is equal to 3,600 divided by 900. The volume of the water required is equal to 3,200 divided by 800 into base period of 120 days multiplied is equal to 424 cumex per days. Next, another is also given, that is called vegetables. In the vegetables, see that one, 1400 divided by 700 into multiplied number of day base period is equal to 120. That is equal to 1400 divided by 700 into 120. That is equal to 240 cumex of the days given. Hence, the total volume of the water required is equal to all the crops 320 plus 2520, 342, 426 and 240. That is equal to 3848 of the cumex of the days. 1 cumex per day is equal to whatever you have to calculation following of the 1 into 24 hours into 60 unto 60, that is equal to meter cube. That is 1 hectare meter is equal to 1 into 10 to the 4 of 4 meter square after the conversion. 1 cubic day is equal to 1 into 24 into 60 into 60 divided by 1 into 10 to the power of 4 hectares meters. That is equal to 8.64 hectares meter, as we previously discussed about the while duty and delta and the base period. Hence, the total volume of the water required on the field is equal to 3848 into 864 is equal to 33,300 hectares meters. Since the losses in the canals of the system is equal to 20% of the volume of the water required, and head of the canal, that is 300 into 10 100 divided by 80, that is equal to 41,800 hectare meters. If the allowing the 12% of the reservoir losses, as already given in the data, 12% is given, the capacity is equal to of the reservoir 41,600 into 100 divided by 88, that is 4,800 hectares as per the given data. So these are the problems, some of the problems we are trying to solve from the irrigation regarding the duty and delta and base period. Hope you understand and utilize these sessions for the examination purposes or entrance examination, whatever it is. Thank you very much.
Like, share and subscribe. Hit the bell icon for more updates.